It's just a flyover, like I said, the original plant before any upgrades were done. The treatment plant was originally built in 1965. Those tanks down in the lower right-hand corner, I believe, were originally built in 1965. This upgrade cost $10 million, and it was 46% grant funded by RUS. Like I said, these were the original tanks from, I believe, 1965. You can see here's the aeration tanks. Here's your final clarifiers. Over here is the chlorine contact tank. A good down view. At one time, I believe this was the digester. Okay, it's just another aerial view coming down on the existing plant before upgrade. Near the end of this slide, you're going to see some lines getting drawn on here, which will show the original flow pattern into the plant. On the left-hand side is the flow coming from the west side of the township. It came into the building here. There was a small pump station here, which had 2 pumps originally. The other flow here is from the east side of the town, which came into gravity. So what originally happened was, like I said, the west side came to here. It was pumped up to here. The east side came into here, and the headworks was between these 2 spirodigesters. As the flow went into these 2 tanks, these spirodigesters were basically primary clarifiers. Worked something like an Imhoff tank. Then after the upgrade, the effluent from there went into the aeration process. But now that they installed 3 new pumps in here, which we'll see. These were the new pumps that were to be installed. These pumps went in this building. This is the completed pump station after the pumps were installed. Come out very well. There's room down there to work on things. Next part of the upgrade was the only real building that was built during this upgrade. All the other tankage and so forth was repurposed. There was a headworks building built here, and what they did, they changed the flow pattern. So they extended the gravity line into the headworks building, and the pump line that was coming from the west, these 3 new pumps now pump it into the headworks building. This is the automated screen. Flow is coming in this direction. It's a band screen, so the flow comes into the center of the screen and then goes out each side. Okay, now we're going to move on to the aeration tanks, plural, 2 trains. This was converted to an IFAS system, which is integrated fixed film activated sludge. The way this system works is there's a couple different technologies for IFAS. This is a fixed media that stays stationary, and as the air comes up through here, you get a biofilm growing on this media, which actually helps raise the bug population and gives you more treatment in the same amount of space in the tank. We're going to move on to the final clarifiers. Originally, there were 2 clarifiers. A third one was built. This was in the 80s as they changed to ammonia removal. But now all 3 of these final clarifiers will receive flow from the IFAS tanks. I believe 1 train goes to 1 large clarifier. The other train goes to these 2 clarifiers. This was the original scraper system and center shaft. All this material is removed. Here's the new center shaft and the new gear drive and the new feed well. These things are called Stanford Baffles or energy dissipating baffles. So the purpose of these, the flow will come in, down, hit the floor, follow the wall, but when it hits this baffle will redirect the flow back into the center of the tank. So you end up with better settling and a better effluent. Other item I want to talk about are these right here. These are called launder covers. Again, when this is complete, it will cover the complete launder of the clarifier. You'll see that in a later picture. I just thought this was a good photo to show you exactly what they do cover. So you're covering the launder and you're covering the weirs. This greatly reduces algae growth which makes maintenance of these clarifiers a whole lot better. As I said, Ed Gould, the operator, I spoke with him before these things were installed. They would spend, a day or two every week scrubbing these clarifier weirs. When these are installed, you have no light getting through to the launders, so you don't get barely any algae growth. So he said what they do about once a month, these panels, which are about 4 foot each, it's a little hard to see here, they actually open this way, so they go around and tilt them all up, take a high pressure hose, wash around in there, and flip them all back down, when they're finished. So it went from, 2 days a week to 1 day a month to clean the clarifiers, which was a huge time savings for the operators. Next, we'll move over to the what was the chlorine contact tank and has now become a UV tank. They actually covered the chlorine contact tank. I'm sorry, it's now the UV tank. The UV disinfection units are here. They're in-channel units. This structure that you see right here houses a lifting crane, so if they need to pull the units out, they have the ability to do so. And now we're going to move on to the digestion part, aerobic digestion. So these tanks from 1965 were repurposed into aerobic digesters. Basically, those tanks were gutted. This is the aeration mechanism for the aerobic digester. This is a bit of a unique system. We've used these in pretty many round tanks and also in square tanks. So the air pipe is, as we'll see in a later slide, the air pipe is going to connect right here. These are the diffusers that go down into the tank, and there'll also be ones that go in these outside ones. These diffusers do not go all the way to the floor. This pipe here works as almost like an air pump. As the diffuser releases air, it actually pulls the sludge in and up out of this pipe, and they do the same thing here. So with the diffusers not having to run all the way to the floor, there's not as much power consumed with the blower to be able to force that air down. This is what it looks like with both the tanks finished. The blowers for the aerobic digestion are back here. There's 3 blowers. There's also a SCADA system added into the plant so that they can monitor everything around the plant from one spot. This particular plant is run by 2 gentlemen. That's it. There's only 2 operators at this plant. So that's why they came up with a lot of labor-saving ideas with those launders and stuff like that. And this is the completed project showing the digester covers, the new headworks building that was built here, and the structure that's used to lift the UV units.